Welcome to Study Loop.
Let's make a substitution to rewrite this integrand as a rational function. Looking at the numerator, we should just take u to be e to the x. Then du is just e to the x dx. So we can rewrite this integral as, well, the numerator, that's just du. Now in the denominator, that becomes u minus 2. And then we have e to the 2x there. So e to the 2x is just e to the x squared, which is u squared. So we have u squared plus 1. Then we have to check whether or not this quadratic factor will factor into two linears. So to do this, you look at the discriminant. B squared minus 4ac. In our problem, b is 0 because there's no u term here. So 0 squared minus 4, a is 1, and then c is 1. So we get a negative quantity. That means that this quadratic does not factor. So using case 1 and case 3 in your textbook, and then for the second fraction, bu plus c. And then we should go ahead and decide and actually find a, b, and c. So really what we should be having here is, let's ignore the integral for a moment. We have 1 over u minus 2, u squared plus 1. By our previous reasoning, multiply both sides of this by the denominator on the left. And that's what we get on the right. And then we just go ahead and simplify that right-hand side. Au squared plus a, bu squared, cu minus 2bu minus 2c. And then we can go ahead and combine like terms. So let's pull out a u squared. We get a plus b. Let's pull out a u. And when we pull out a u, we have c minus 2b. And then a minus 2c. Okay, so now we match the coefficients on the left and the right. On the right, actually, let me start on the left. We see that the constant term is a 1. That means a minus 2c is 1. And since there's no u or u squared on the left, that must mean that a plus b and then c minus 2b are both 0. So let's write and solve the system on the next page. A minus 2c equals 1. So we also had a plus b equals 0. And then c minus 2b equals 0. So for example, here we have a equals negative b. Here we have c equals 2b, which we could write as negative 2a from this equation here. And so coming back to this equation up here, we have a minus 2c, but then c is just negative 2a. So this becomes a plus 2 times 2a equals 1. So we get a equals 1/5. Then from this equation here, b is negative 1/5. And from this equation here, c is negative 2/5. Plugging these back into the integral on the first page, after we plug in for a, b, and c. So that's a u minus 2 down there, and then plus and then minus 1 over 5, and then times u, minus 2 over 5. That was our b and c terms. U squared plus 1 du. Now we can go ahead and split this into 3 integrals. So let's write that next. Actually, let me go to the next page here. I'll need more room. You pull out the constants and split up all these integrals as much as I can. That's the first one. Then I pull out a negative 1/5 from the second one. U over u squared plus 1. And then pull out the minus 2 over 5 from the last fraction. 1 over u squared plus 1. And we have a du there. For the first integral, if this minus 2 is bothering you, do a u substitution. You'll get 1 over 5, natural log, u minus 2. For the first integral, then for the second, you can do a u sub here as well. So let w be u squared plus 1. dw over 2 is just u du. So we have one over w dw, natural log w, and then back substitute. And if you want, you could drop the absolute value here because u squared plus 1 is positive. So then also multiply by this negative 1 over 5. So we get negative 1 over 10, natural log, u squared plus 1. And then for this last integral, we just memorize this as arctan. And now if you had forgotten that fact, that's perfectly fine. And the way that we would evaluate this is we would have to go to the side and do the trig substitution, u equals tan theta. And to simplify, you'll end up with tan inverse theta when you integrate. We added our constant c. The last step here is to replace u with x. So let's just go ahead and do that. ln, that's e to the x. That was how we defined u. And then technically here, I should keep my absolute values there. Minus 1 over 10. And then e to the 2x plus 1. And then minus 2 over 5, tan inverse, e to the x, plus our c, and that's our answer.